Okay, objective 2 we have up here now is to use negative exponents to write numbers in scientific notation. Okay, so this is example 7. It says write this number in standard form. So the first thing I'm going to do is just rewrite down the number. Okay, and then I'm going to write down just this first part, the decimal part here, 1.5. Then I'm going to look at my steps. Okay, if the exponent is positive, we move the decimal to the right. And step 2 says if the exponent is negative, we move the decimal to the left. Well, the exponent here is negative, so I'm going to move the decimal to the left this many places. So it's going to go to the left 3 spots. So I'm going to count 1, 2, and then 3, and throw my decimal out here in front. Okay, then of course we would fill in 2 zeros here. Then step 3 is to rewrite this number in standard form. So I'm going to put 0.0015. Okay, and I like to throw zeros out in front here, so 0.0015. Okay, and that's how we write numbers in scientific notation with negative exponents. Let's go on to the next example. In this example, it says the diameter of a red blood cell is about this many meters, and we want to write that in scientific notation. Okay, so the first thing I'm going to do is write this number down. There are 5 zeros there. We want to write in scientific notation. Remember, scientific notation is a number times 10 to some power. Okay, and the first number has to be between 1 and 10. So I need to put a decimal in this to make it between 1 and 10. So that would make it, or I would have to put it after the 7 right here. Okay, to be between 1 and 10. So my first number I'm going to write down is 7. I'm going to put times 10. And I need to figure out how to move the decimal to get to the number I started at. So I would move it 1, 2, 3, 4, 5, 6 places to the left. Since I would move it to the left, it's a negative exponent, and it's 6 places. Okay? And we're going to label it with meters. So again, figure out where the decimal goes to make your number between 1 and 10. And then from that spot, count how many places you had to go to get to where the decimal actually is. So we moved it 6 places to the left. So the negative tells us to move it to the left, and it was 6 places. Now we got one last example. Okay, this example says to compare 1 times 10 to the negative 6 to negative 10. Okay, well I know what negative 10 is. That's pretty easy to compare with. So I'm going to convert this to standard notation first. Okay, so 1, oops, sorry, got to get my correct pen here. So 1 times 10 to the negative 6. Okay, so if I could write this number with a decimal in it, it'd be like this. The negative sign tells me to move the exponent to the left, and the number tells me 6 times. So if I move this decimal 6 places to the left, it goes 1, 2, 3, 4, 5, 6, and our decimal goes here, and we fill in all this with zeros. So this number is the same as 0.000001. Well, we should know that this is a positive number, and any positive number is bigger than a negative number. Okay, so the answer is greater than. And it doesn't matter how small this decimal is, any positive number is bigger than a negative number all the time. So this, even though it's really tiny, is still bigger than negative 10. And that's it for your lesson, so good luck on your homework.